Walk through almost any major tech company right now, and you'll notice something most people don't talk about out loud. The desks where junior developers used to sit are quietly disappearing. The teams that used to have 10 engineers now have 3. The mentorship programs that used to bring new graduates into the industry have been paused, restructured, or quietly canceled. Nobody's announcing layoffs. There's no dramatic press release. The pipeline is just slowly going dark. And in our MEIA analysis, this is the cascade with the longest tail and the deepest consequences. We've spent 3 episodes mapping how vibe coding strains physical infrastructure, breaks insurance markets, and dissolves legal responsibility. But every one of those previous failures assumed something I want to challenge directly today. They assumed the people who could see these problems coming and the people who could fix them once they arrive would still be in the room. Our analysis says they won't be. Not because they're being fired, because the entire structure that produced them, trained them, and rewarded them is quietly being dismantled. And the thing nobody is preparing for is what happens when the institutional knowledge of how software actually works walks out the door. And there's nobody coming up behind them to learn it. The first mechanism is the simplest, and the one that's already happening. Junior developer roles are disappearing. For decades, the entry-level software job served 2 purposes. It gave new engineers a place to learn the craft, and it gave senior engineers a place to delegate the work that wasn't worth their time. AI just collapsed both of those functions. The work that used to go to a junior developer, boilerplate code, simple bug fixes, routine documentation, that work is now done by an AI in seconds for almost nothing. So companies stop hiring juniors. Why would they pay $40,000 a year to train someone when an AI can produce more code than that person could in a month? It's a rational decision at the individual company level. It's catastrophic at the industry level. Because the senior engineers we have today were the junior engineers of 10 years ago. There is no way to grow a senior engineer except to hire a junior one and let them work on real problems for years. When you stop doing that, you don't notice the problem immediately. You notice it a decade later, when the senior engineers retire and there's nobody to replace them. The second mechanism is what happens to the senior engineers we already have. Remember from episode 1, when AI generates code, humans still have to review it. And reviewing AI-generated code is fundamentally harder than reviewing human-written code. Human code follows patterns. It has a logic you can predict. AI code can be syntactically perfect and semantically broken in ways that don't show up until production. So the senior engineers who used to mentor juniors and architect systems are now spending the majority of their time auditing machine output. The role they were promoted into has been replaced by something most of them didn't sign up for and didn't enjoy. And the volume just keeps climbing. Our analysis tracks the same pattern we covered in episode 1 with open source maintainers, just inside enterprise teams. The math doesn't work. A senior engineer can produce maybe a few hundred lines of carefully reviewed code per day. An AI can generate a few 100,000. The ratio is impossible. So they burn out, they quit, or they stay and become deeply, quietly unhappy, which is its own kind of leaving. The third mechanism we covered in episode 1, but it deserves its own moment here because it operates on the same principles as the enterprise burnout, just with even less protection. The open source maintainers, the unpaid volunteers who keep the foundational libraries of the internet alive, are facing the same mathematical impossibility, but without a paycheck to compensate for it. AI lets anyone generate thousands of pull requests per hour, and the maintainers have to evaluate every single one because they don't know which contribution is sincere and which is hallucinated nonsense that compiles cleanly. The probability of mass maintainer resignation in our analysis sits between 5 and 25%. That sounds low until you remember what happens if it triggers. The libraries that stop receiving security updates are the libraries that everything else depends on. OpenSSL, curl, core-js, frameworks that are inside almost every commercial product on Earth. When those go untended, the entire downstream ecosystem inherits the risk. The fourth mechanism is the slowest and the hardest to see while it's happening. We touched on it at the end of episode 1, but it's worth giving its full weight now because we think it's the deepest of the four. When humans stop writing software from scratch and only edit AI output, something gradually disappears that nobody was tracking. The capacity to recognize what correct software actually looks like. Reading code is not the same skill as writing it. Editing a draft is not the same skill as composing one. There's a difference between a pianist who can play a piece and a pianist who can compose one. And over a generation, if we only ever hire editors, the composers stop being produced. Our analysis can't put a clean probability on this one because cognitive erosion happens too slowly to see in any given year. But it tracks with what cognitive scientists already understand about skill atrophy. If the next generation of engineers spends most of their working lives reviewing AI-generated logic instead of building from first principles, our collective ability to even recognize when AI is wrong slowly degrades. And the AI keeps producing. Nobody notices the bar dropping until something serious breaks, and the room full of editors realizes there's nobody left who knows how to write the thing from scratch. I want to address the obvious counterargument here, because anytime you talk about workforce displacement, someone reasonably asks, haven't we been through this before? Cars replaced horses. Spreadsheets replaced manual ledgers. The internet replaced entire categories of jobs. And every time, the workforce eventually adapted. So why is this different? Our analysis identifies one specific structural difference, and it's the difference that matters most. In every previous automation wave, the new tools amplified what skilled humans could do. A spreadsheet made an accountant 10 times more productive. The internet made a researcher 100 times more productive. But the accountants and the researchers still had to exist. They still had to learn the underlying craft. AI code generation is the first wave where the tool doesn't amplify the skill. It substitutes for the learning curve itself. You don't need a junior developer to understand the work because the AI does the work, which means you never grow the senior developer who would have come from that junior. The pipeline doesn't just shrink, it stops producing the people who would refill it. Here's what our analysis suggests organizations should actually do. And these aren't comfortable recommendations. Most of them require accepting short-term cost in exchange for long-term survival. First, keep hiring junior developers, even when the spreadsheet says you don't need to. Treat it as infrastructure investment, not headcount. Second, protect your senior engineers from review burnout by rotating them out of audit duty regularly and back into greenfield design work. The skills they're losing matter more than the throughput you're gaining. Third, fund open source maintainers directly. Pick the libraries your business depends on and pay the people who maintain them. This is one of the highest leverage interventions in the entire MEIA framework. The cost is trivial. The downside, if you don't, is existential. And fourth, build internal knowledge transfer rituals that don't depend on AI. Pair programming, code archaeology sessions, architecture reviews where people explain what the code does in plain English. The point isn't efficiency. The point is preserving the cognitive muscle that lets humans recognize what correct looks like. The deeper question underneath all of this is one that's been quietly running through every episode of this series. What happens when the people who hold the institutional knowledge of how complex systems work just stop being produced? It's not a sudden collapse. It's not dramatic. It's a slow dimming. The lights stay on for a long time after the people who knew how to fix the lights stopped being trained to fix them. The systems keep running. The code keeps shipping. Until one day, something breaks in a way that nobody in the room knows how to diagnose, and the realization hits all at once that the experts we used to call when things went wrong don't exist anymore. We didn't replace them. We just stopped making them. We've covered 5 cascading failures, 4 possible futures, the legal collapse, and now the workforce crisis. 5 episodes mapping different parts of the same system. Next time, we pull all of it together and try to answer the question that should be on every decision-maker's mind right now. If this cascade fully unfolds, what actually breaks first? Not the most likely failure, not the most catastrophic, the one that triggers everything else. We map the early warning signals across all 5 threads and identify the single signal that, if you only watched one thing, would tell you which version of the future is actually arriving. Next time,